Okay, YouTube, in anticipation for our notes on matrix operations, we're going to start looking at notations that we use with matrices in the first place. So some pretty standard things in terms of how we write matrices and how we indicate something is a matrix and its elements. So let's take a look at what we have here. It says that we've seen that an array of numbers arranged in rows and columns and placed in brackets, we call those things matrices. But what you might not have known is that we represent matrices two different ways. So one way to do it, is just by a capital letter. So we often use capital A, B, or C. Those are pretty common there for matrices, but we use these capital letters to denote that matrix. But we also say that a lowercase letter enclosed in brackets, such as the one shown below, can denote a matrix. So what you'll see here is this, that our matrix A, okay, is given on the left as this capital letter A, but sometimes we write it as with these brackets here. And of course, we've seen matrices that have brackets around them, all matrices do. But what you see on the inside of this is just little aij. And so what this is representing are all of the individual elements that are inside of this matrix. So generally speaking, when we talk about a general element in matrix A denoted with this lowercase letter a, we use this little subscript I and j. And so what this is referring to is the element of A in the ith row. So we kind of indicate the ith row and jth column. So we use this kind of ij indication to indicate what row and column you're in. So for example, if we were to say lowercase a, which is in our capital A matrix here, 3, 2 is its subscript, this would literally mean that this is the element in the matrix that's in the third row and second column. So we have third row, and then we'll twist this over here. We say second column. So we're going to be representing matrices using this notation quite often here. Let's go ahead and take a look at the order of a matrix. We say that every matrix does indeed have an order, and often we refer to this in general as some m by n, but what you're looking at is that it has m rows and then n columns. So it's always going to be rows by columns, which is kind of an important thing, always rows before columns. But when we describe the order of the matrix, you're really just giving its dimensions. So we say that if the dimensions of rows and columns here are equal, then the matrix has the same number of rows as columns, and we'll refer to that as a square matrix. Okay. So looking at this matrix notation idea down here, it says that if we let A equal this matrix right here, the two things we want to do are indicate the order of A, but also if A is equal to this set of little itty bitty A's in the ith row and jth column, could we identify the element A23 and element A12? So let's go ahead and start with the order of this. Because it's rows by columns, and rows always run laterally and columns run vertically, we're going to see that this has 2 rows and 3 columns. And so the order of this is just, we would simply write this is a 2 by 3 matrix, and that's how you would read it as well. And with respect to A23 and A12, let's go ahead and write these down. We say A23 equals and A12 equals. So when we look in here and we say 2, 3, we're really indicating the entry that's in the second row. Okay, so we have the second row, here's the first row. And we would say here's our first column, second column, and third column. Then we're really indicating the thing that's in the second row, third column. So that would be equal to this entry here. And so we say the value of A23 is really -1/5. And likewise, we say A12, well, this would be in the first row, but second column, this would be this entry here. So that element of this matrix has a value of 2. So what I'd like for you to try is just identify the order of this matrix A that you see over here, but also identify A12 and A31. Cheers.